Hi guys, what we're going to be looking at today is we're going to be looking at equivalent fractions and what they mean. For the word equivalent, I want you to try and think that equivalent is just another word for equal fractions. So we're going to investigate that. We're going to meet a couple of key words here, which is numerator and denominator. Okay, so let me take the fraction to start us off with 3/4. So I refer to the denominator is 4, and that is the number on the bottom, and my numerator is the number on top. Okay, so they're the two key words that we'll be using and discussing when we're talking about different types of fractions. Here what I've got is I've got an equivalent fraction wall. Alright, and this is probably something that you've seen in primary school, and what it does is it helps us visualise what fractions are the same. So if I was to go in and I was to give someone half of a pizza, okay, alright, and it's just appeared here. So if I was to give someone half of the pizza, it would be represented by this fraction, and we can use the fraction wall then to tell us what is also equal to that. So I can have a look, and if I was to give someone 2/3, well, that would be bigger than a half, but exactly a half is 1/4 and another 1/4. So 1/2 is also the same as 2/4. So that's 1/4 here and 1/4 here. Alright, and we say that those fractions are equivalent. So 1/2 and 2/4 means the same thing. Here I'm going to use my fraction wall to figure out other examples of numerators and denominators. So here I can see that the denominator I'm dealing with here is 6, which means I'm dealing with sixths. So here my fraction wall is divided evenly into 6 equal parts, and each one is referred to as 1/6, so 1 out of 6 blocks. And I need to figure out, well, what is equivalent to 2/3? So I can see here at the top that this first line is divided into 3 parts, 1, 2, 3, and there are 3 equal parts and each one represents a third. So what would 2/3 be? Well, I'm going to shade in 2/3. So first of all, I've shaded in 1/3 and I've shaded in 2/3. So from looking at the fraction wall, how many sixths is equal to 2/3? Okay, well, hopefully everyone is looking at this line here, which is the 6th line, and I can see that if this is where I start and this is where I finish, I'm going to make a thicker line just so you'll see that we should be able to see that this represents 1, 2, 3, 4. So this represents 4/6. So if I was to offer someone 4/6 of the pizza, or I was to offer them 2/3 of the pizza, they'd both be getting the same thing. So they'd both be getting equal fractions. Alright, how many ninths are the same as 2/3? So again, I already have my 2/3 mapped out here, and we're asked the question, how many ninths? Okay, so I'm just going to do this in a different colour to help us out. So, I hope everybody is looking at this one here, which is the fraction bar, and it has divided this into 9 equal steps, okay, and equal boxes. So each one of these boxes represents 1/9. So how many ninths is there in 2/3? So there's 3 in 1/3. Yeah, keep going. Okay, so can we figure that out? There is 1, 2, 3, 4, 5, 6. So there is 6/9 in 2/3. So they are both the same fraction. They are equal fractions or equivalent fractions. And the last question is dealing in 12ths. So the denominator here is a 12. So we're staring, hopefully, at this one here, which is my fraction bar that has been divided evenly into 12 equal parts. And we are asked, how many 12ths is there in 2/3? So can count that up. I'm going to use green this time. So 1, 2, 3, 4, 5, 6, 7, 8. So 8/12 is the same as 2/3. And what I've done here is I've placed 2 pizzas. This pizza is cut into 3 equal parts. So we say that each slice represents 1/3. And over here I have this pizza, which is cut into 12 equal parts. And so we represent 1 slice here by the fraction 1/12. And I am after saying that 8/12 is the same as 2/3. So let's see if that is the case from visualization. So 2/3, I'm going to fill in 2/3 on this pizza here, which means I am going to cover this, which is 1/3, and I'm going to colour this one here, which is 2/3. So if I was to offer you 2/3 of the pizza, I'd be offering you this amount here. Or I could say, right, you could have 8/12 slices. So let's count that. 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to fill them all in a little bit thicker. And what you should see is that if I was to offer you 2/3, or if I was to offer you 8/12, there really wouldn't be much of a decision because I'm basically offering you the same thing. So I'm giving you an equal fraction or an equal portion. But what about being able to do this without the fraction wall? Quite difficult for us to draw a fraction wall for everything or every time we needed to do a sum. But fortunately that's not the case. Our keywords will help us out here. Alright, and our keywords are the numerator and the denominator. Remember, the numerator is all about the number on the top and the denominator is the number on the bottom. So here I'm given the fraction 4/5 and I'm asked, well, what is that equal to? And I want my answer to be in 15ths. I'm going to use my denominator here to help me do that. And I'm going to use the operation of multiplication. So what I want people to do is when they're asked for equivalent fractions is to draw an arrow from 5 to 15. And then we're going to ask ourselves a question. And that question is, what do I need to do to turn the 5 into a 15? And what I actually need to do here, guys, is in order for my 5 to become a 15, I need to multiply the bottom line by 3. And the way I read that is 5 multiplied by 3 gives me 15. The second thing I need to say to myself is, what I do to the bottom, I must also do to the top. So on the bottom here, I multiplied it by 3. I must then go ahead and multiply the top by 3. And now I'm in a position where I can figure it out. 4 times 3 is 12. So the actual answer here, 4/5, another way of saying 4/5 is the same as writing 12 out of 15. And that's how we can solve equivalent fractions without using our fraction wall. We follow these 2 steps. What I do to the bottom, how do I get 5 from a 15? Well, I multiply it by 3. And what I do to the bottom, I must do to the top. Example 2 here asks us to make an equivalent fraction of 3/9. So 3/9 is the same as something over 18. And I'm going to follow my 2 steps. The first thing is I draw my arrow from 9 to 18 and I ask myself the question, what do I have to do to 9 to get 18? And the answer is I must multiply it by 2. Let's recheck. 9 multiplied by 2 gives me 18, so that works. And then I say to myself, what I do to the bottom, I must do to the top. So I'm now going to draw my arrows from here to here, and I'm going to write multiply by 2. And then I'm going to solve. 3 multiplied by 2 gives me 6. So there you have it. 3/9 is the same as 6 over 18. Okay guys, we're going to move on and I'm going to get you to do the next few sums here in your copybooks. Alright, this is going to be a little bit of a learning check. There is a few little things though that I want you to notice. If a number is smaller and it becomes bigger, the operation will be multiplication. So you'll be saying it goes from 3 to 15. So what is happening here on the bottom? What do I do to the 3 to get 15? Well, I multiply it by 5. Okay, and I'll let you guys finish the rest of that one off. But if we have a look at this one here, the denominator here is 10 and it goes to 5. So we are going from a larger number down to a small number. And we have a different operation here. So again, we start with drawing our arrows. Okay, and then I ask myself, what do I do to the 10 to get 5? How do I get 5 from 10? And the answer here, I'm going from a big number to a small number. That is the operation of division. And in this case, it's divide by 2. 10 divided by 2 gives me 5. And I said before, what I do to the bottom, I must do to the top. And I'm going to write divide by 2 up here. And what number divided by 2 gives you 3? So they've given you this part, we need to fill out this. So what number divided by 2 gives you 3? And the answer is 6. Okay, so there's a few questions for you guys to try. These ones here, they're going from small to big, small to big, small to big, so your operation will be multiplication. And here we're going big to small, big to small, big to small, so your operation here will be division. Alright, so that brings us to the end of today's lesson and today's learning check. So go back through this, make sure you know your keywords and are able to tell me and explain how to find equivalent fractions.